All right, let's dive into something that's on every developer's mind these days. How do we go from just using an AI coding assistant to actually directing it? We're going to talk about building some smart, automated guardrails to make our AI teammate not just faster, but safer and a whole lot more effective.
Oh, we've all been there, right? You give the AI what feels like a super simple, helpful task. And, well, it does exactly what you asked. But in the process, it completely misses some critical dependency or a call site buried in another file. And just like that, your whole build is broken. It's that frustrating moment where a supposed time saver suddenly becomes a massive time sink.
So why does this keep happening? Well, the truth is, even the most powerful AIs out there have some serious blind spots, especially when you drop them into a big, complex, real-world code base. They just don't have that deep context a human developer builds up over months or even years.
And if you look at this list, I bet it feels pretty familiar. You've got the classic ripple effect. The AI changes one function signature, and suddenly you have a dozen type errors it didn't see. Or, my personal favorite, it just reinvents the wheel. It writes brand new code because it has no idea a handy utility function for that already exists. It can also totally ignore your team's coding style. Or, and this is a big one, it might even try to read a sensitive file like your .env, which is a huge security no-no.
Okay, so this is where we get to take back control. The solution is this really powerful, but actually pretty simple, concept called hooks. Seriously, just think of them as automated guardrails that you build around your AI. They keep it on the right path and make sure it plays by your project's rules.
So what is a hook, really? At its core, it's just a command or a script that you write, and it gets triggered automatically whenever the AI, in our case Claude, tries to use one of its built-in tools, like reading or writing a file. This gives you this critical moment to step in, check what it's doing, and even block or improve its action.
And this diagram just lays it out perfectly. You ask Claude to do something. Claude thinks, okay, I need to use a tool for that. But right before it actually runs that tool, a pre-tool use hook can jump in. And then right after it's done, a post-tool use hook can run. You literally get to inject your own custom logic right into the middle of the AI's workflow.
Now, understanding the difference between these two is absolutely key. Pre-tool use hooks are your proactive defense. They're like the bouncer at the door. They run before anything happens and can stop the action completely. This is perfect for things like security, telling Claude, nope, you are never allowed to read that .env file. Post-tool use hooks, on the other hand, are reactive. They're the quality inspector at the end of the line. They run after the action. They can't stop what already happened, but they can check the result, say by running a code formatter or a linter, and then feed that feedback right back to Claude.
All right, theory's great, but let's see what this actually looks like in the real world. We're going to walk through two incredibly powerful examples that show just what's possible here.
Okay, this first one is a total game changer for anyone using TypeScript. So, imagine Claude refactors a function. The moment it saves the file, our post-tool use hook kicks in and runs the TypeScript compiler. Of course, the compiler finds all those broken call sites that Claude totally missed. The hook just grabs those error messages, feeds them right back to Claude, which then goes, oh, my bad, and immediately fixes the code it just broke. It's a completely automated feedback and self-correction loop. It's awesome.
Now let's get a little more advanced. Let's say you're on a massive project with hundreds of existing functions and database queries. You ask Claude to do something, and it decides, I'll just write a new query to get pending orders. It has no clue that a perfectly good function for that already exists. This is how you get code bloat and tons of inconsistency.
And the solution here is, well, it's brilliant. A pre-tool use hook intercepts Claude's attempt to write that new file. But then it does something amazing. It programmatically spins up a second, totally separate instance of Claude, whose only job is to be an automated code reviewer. It scans the codebase for any similar functions. If it finds one, it blocks the original Claude's action and basically says, hey, stop, don't write new code, just use this function that already exists. How cool is that?
So this all probably sounds amazing, but you might be thinking, is this super hard to build? And the answer is, not at all. The whole process is actually incredibly straightforward and just makes a lot of sense.
It really just boils down to 4 simple steps. First, you decide, do I need to act before or after the tool runs, pre or post? Second, you tell it which tools you care about. Are you watching for an edit, a read, a write? Third, you write your script that does the actual work. And finally, fourth, you just use simple exit codes to tell Claude what to do next.
You set all of this up in a simple settings JSON file.
And what's really great is that you can define these settings at a global level for all your projects. You can do it at a project level to share rules with your whole team, or you can even have a local file for your own personal guardrails. It's super flexible.
So you're probably wondering, how does my script even know what the AI is doing? Well, it's simple. Claude just pipes a clean JSON object right into your script's standard input. And that JSON tells you everything you need to know. The name of the tool, like read, and all its parameters, like the exact file path it wants to access. Your script gets all the context it needs to make an intelligent decision.
And talking back to Claude is just as easy. Think of it like a traffic light. If your script exits with code 0, that's a green light. It means all clear, go ahead. But if it exits with code 2, that's a hard stop. It's a red light. And the best part is, with exit code 2, anything your script writes to standard error gets passed directly to Claude as feedback, explaining exactly why its action was blocked.
Now, as powerful as hooks are, it's important to remember they're really just one piece of a much bigger puzzle. They're part of a whole ecosystem designed to let you completely customize and automate your AI assistant.
I mean, we're talking about a whole universe of automation here. You can build custom tool servers to give Claude brand new skills, like being able to control a web browser. You can use the Claude Code SDK to run the AI from inside your own scripts, or even your CI/CD pipelines. And you can wrap it all up with things like GitHub Actions to bring it right into your team's day-to-day workflow.
And this is really where it all comes together in a beautiful way. With the GitHub integration, you can literally just add Claude in a pull request or an issue, and it'll get to work. Or you can set it up to automatically review every single PR, giving you an impact analysis before a human even has to look at it. It stops being just a tool and starts being a true automated member of your team.
So, what's the big takeaway from all this? The big picture? It's that all of these features, hooks, SDKs, all of it, are really about one core idea: giving you, the developer, the power to truly govern your AI assistant.
It's about making this shift, transforming the AI from just a simple tool that spits out code into a genuine development partner, one that understands your project's rules, plugs into your entire toolchain, and operates safely and effectively within the boundaries that you set.
And that really just leaves us with one final exciting question. Now that you know how to build these automated guardrails, what are you going to create? What tedious code reviews, what quality checks, what repetitive tasks in your own workflow are you finally going to automate? I'm excited to see what you come up with. Thanks for tuning in.